Yes, hello. Yeah, I'm back from my summer holidays and have a lot of new stuff in my backpack. Today we will have a very technical topic. Okay, I know some of you will say simulator controller is already technical enough, but yeah, I can tell you it can get even worse. As always, here in the Discord, jump in, ask questions, interrupt me if something is not clear enough, and let's have some fun. The topic for today is extending and customizing our well-known assistants by using a large language model. It's a follow-up to the last coaching sessions where we already introduced the large language model support to make the conversation much more lifelike, because the large language model supports you in rephrasing and understanding and stuff like that. But I managed to include the large language model, or the GPT service, as some of you might be more accustomed to as a name for it, also in the reasoning process for the activities an assistant will take. Okay, let's start with a very short wrap-up of the last things, because it's important for understanding the stuff of today. We can connect the assistants to a GPT service, which means that the round trip between you as a user and the assistant, which has been implemented using a rule engine — we will come to the rule engine later on — is extended by a jump out to a large language model which can do its own things. And what already has been there is, let's take a look here, the possibility to use a large language model for rephrasing, which means you can, the answer or the text the assistant will speak to you will be sent to the GPT service with the with a command to rephrase it, to bring in some variation in the phrasing of the command or the sentence. The second one is understanding, which means that the large language model is asked to translate commands from you as a driver, which does not adhere to the fixed grammar which has been used in the past, to one of the predefined grammars. So the large language model translates between you and the understanding of the assistant, which allows you to give commands much more freely than it was before. And the last one, which we also introduced in the last coaching session, is the conversation booster, which means that every command which is not detected as one of the predefined commands will be given completely to the large language model to answer. So you can talk to the assistant absolutely naturally, and the assistant will try to answer your questions or help you with whatever you have in this exact moment. We will have a demonstration in a few minutes. What's new now is that we can attach so-called actions to the conversation, which means that the large language model is able to act on your commands or on your whatever you told him. It's very much like for example, you have an uncensored large language model and you ask how to end the climate crisis. And there is an action available which says, you can press this red button to remove all humans from Earth. This will end the climate crisis. Maybe the large language model will decide to do it, if it's uncensored. If it is one of the good models, it will refuse to do it, of course. our domain is much more simple, but if the large language model, for example, decides to give you not enough fuel for the next pit stop, this will be even worse than the complete extinction of humans. And also new, and this is the main part of our today's session, is the so-called reasoning booster, which is a very, very capable thing, which allows you to give the large language model complete control over the actions of the assistant. Okay, to use all that, you have to configure one of the providers. I'm using at the moment OpenAI very often, using GPT-4o Mini. It's a model which has been introduced 1 or 2 weeks ago by OpenAI. It's much more capable than GPT 3.5, which I recommended before, and it's even cheaper. It's a really, really great model. You can configure 2 different models, one for conversation, for all the stuff here, and one for the reasoning. This is because the requirements to the large language model for conversation is different to that of logical reasoning. There are models which are very good as a chat assistant, and other models are very, very good in reasoning and proving, and so therefore I decided to allow you to configure 2 different models. Okay, let's take a step back here. Where can I configure these models, or where can I attach the GPT services to the assistants? There are 2 places to do this. One is in the simulator setup wizard. In the basic configuration page, you can click here on the rocket icons, which will symbolize the booster kind of action, and this will open this configuration window. You can configure individually for each of the available assistants, but the configuration is also available in the low-level configuration tool, which we will use today because it has a much faster turnaround time than the wizard. And there you can go to the plugins page, select the assistant you want to configure, and have the same booster button here. Okay, so let's start with a few demos to show you what's possible. And let's jump into the rabbit hole and go to the center of the Earth. We will not run a simulator here. I will use a recorded session with some pre-defined race conditions, because that's much easier, much faster. I will start.
Hi, Oliver. This is Tom. I will take care of your car today. Call me anytime.
And we have finished the second lap now, so the learning phase of the assistant is done and the knowledge base is filled with data. And now we can talk to the LLM, the large language model. Let's first ask a very easy question. How many fuel can my car take?
I don't know.
Okay. What is the fuel capacity of the car?
The fuel capacity of the car is 125 liters.
Okay, the first question, he did not understand the first question because it was ambiguous, because how much want you fuel, or how much fuel capacity do you have, but the second question has been answered correctly. This is not one of the predefined commands of the race engineer. You do not have this command. It was analyzed by the LLM, and to answer this question the large language model had access to the knowledge base, to the complete data set which is available to the race engineer. We will see this, how it is structured and where it is available later when we go more technical. Okay, second example. Do we have damage?
No, there is no bodywork, engine, or suspension damage.
Also here, the information is taken from the available data. Now to choose a little more interesting question. What tire sets do we have available?
You have 99 sets of dry, black, tires and 99 sets of wet, black, tires available.
So we are running in a session in ACC apparently where we have dry and wet tires, and 99 means more or less unrestricted, so the session has no restrictions in the number of available tire sets per tire compound. Okay, now for something interesting. As I have shown before, we are still here in the conversation booster, and now we have actions available for the LLM to, let's say, act on your command. And one of the actions is apparently plan pit stop, the most important action for the race engineer. And the LLM knows, okay, using this action he can create a plan for the next pit stop, and he has several arguments available to use to fulfill our demand or the demand from the driver. It's one of the built-in actions, so it's supplied in the standard distribution, but we will see later that you can also define your own actions. The possibilities are endless. Okay, let's use this action and do something which has not been possible before. I must come to the pit. Can we refuel 12 liter, repair all damage, and mount tires for rain?
Wait a minute. This is Tom. Pit stop 1 will be as follows. We have to refuel 12.0 liters. We will mount wet tires. We have some changes for the pressures. 26.8 psi front left. 26.6 psi in the front right tire. Rear left 26.8. 26.4 psi rear right. If this is okay for you, I will let the pit crew get ready. Confirm please.
So
I will check it out immediately.
So the LLM has used this action here and instruct the race engineer rule engine, which has been there all the time, to do the pit stop according to our demand. When you're not using the LLM, you can simply ask, can you prepare the pit stop, and the race engineer will do whatever he will do. And now it is possible to give a very precise instruction using this action here. Okay, I will show you how the LLM can get to the data. This is very simple. Let's take a look here at the customizing assistance. Here, this is the chapter where everything is documented for the LLM integration, and the whole magic is that whenever the GPT service is called and the LLM is invoked, I supply the complete knowledge base which has been collected by the race engineer and the rule engine as JSON object, a structured description of everything which has happened in the last laps. What you have here is full damage information, fuel level, fuel remaining capacity, a description of the last laps with the development of the tire data, brake data, and so on. You have the full history of recent pit stops, so the LLM can take a look what for example, tire pressures has been taken there. A description of the session itself, and here you see, depending on the current simulator and car, I will supply also which are the available tire types with the different compounds and stuff like that. So the LLM has full access to this JSON object and can now use all this knowledge to formulate its answer or decide what to do, what action to be called. Okay, fine so far. Any questions up to this point? Seems not. Are you still there? Oh, Peter, very, very silent. Still very silent. Okay. Okay, now let's come to the fancy stuff. So we have seen the first two levels of the rabbit hole. Let's go deeper. The last booster here, the so-called reasoning booster. I think I will describe what it is doing using a picture. And let's take a look at this one. We had in the past 4 years already a so-called rule engine for the assistants. A rule engine is a kind of programming language which acts on events and takes actions, but you have to predefine rules to give this thing some kind of intelligence. So 20 years ago this was called expert systems, because the approach in the past days of artificial intelligence was to extract the knowledge of an expert using some kind if-then do this rules. And we are using this rule engine for the assistant for quite some time now, and it's really, really effective. But you have to think through everything in advance. You must define rules for almost everything. And I have now extended this rule engine cycle by creating an out loop which goes through an LLM and goes back to the rule engine. It works more or less like that. If anywhere in the rule engine a situation is detected, a so-called event is signaled. A situation may be low fuel, damage, the next pit stop according to the strategy is upcoming, and stuff like that. So it's a situation where the assistant will act upon. The action taken in the past was hard-coded by me. I invented all these rules, but now you have the possibility to simply signal the event and use the LLM to work on the knowledge, the knowledge I have shown before, the complete knowledge base of the assistant, and decide with the set of available actions what to do. If the LLM thinks that one of the actions, or even multiple of them, must be applied to the current event, it will trigger this. These functions or actions will be executed, and they can do several things. They can go back to the rule engine, change the knowledge base, signal new events and stuff like that. They can call functions and methods in every part of simulator controller. For example, I have an example we will see later on. If it starts raining, you can create an action which says, okay, send the keyboard command control V, Control W to the simulator, which enables the windscreen wipers. And you can also generate voice output from the actions, and by using all this, you are now able to completely reprogram, to extend the assistant, to reprogram it, to customize existing behavior, and so on. Before we now jump again into demonstration, let's have a look at the rule engine, because some of your own actions or your own events you can define will have to use the rule engine. And yes, I said it's a technical topic. We have a complete chapter which describes the rule engine. I have tried to keep it as non-programmer friendly as possible, but in the end it's a programming language, and you have to have a little bit of understanding how to use script languages or programming languages. Just as a very, very short introduction, the rule engine has two different kinds of rules. The one are so-called forward rules, which will signal events. For example, this one here says if any of these conditions are met, also if any of these conditions are currently there, and the first condition is we have started a new lap, or we do not have a current target for the refuel amount for the next pit stop, then call this secondary rule, which is quite complicated, which calculates the amount of refuel needed for the next pit stop. You will never have to formulate such complex rules because they are already there, but we will see that 2 to 3 lines of code might be necessary, for example, to introduce a new functionality. Okay, this is this one. As I said before, jump in if you have questions. I know it's a very complicated topic. Okay, do we want to save your changes? No. Then let's take a look here at some of the built-in events, and I will try to explain you the editor you have here at your fingertips to define your events and rules. And as I said before, there are a couple of events and actions already predefined for you to use. You only have to choose it, enable or disable it, and I will extend this set of predefined events and actions with each release, but it is possible to create your own ones. Okay, the most simple one is that an event damage, for example, is signaled by the rule engine, and this event is redirected to a class, to a built-in class, the so-called damage event. As I said, it's built-in. This here is a different beast. Rain started, also built-in, but built-in using some rule engine code. This event is signaled just in the moment when the rain starts. And you can use this event, for example, and we will see this in a few seconds or minutes, to switch on your windscreen wipers, and so on. And if you want to define your own events, okay, here just click on the plus icon, you will get a new line and define what to do, and we will do also this later. Okay, then start with this very simple example with wipers. As we have seen here, the event which is raised is rain start, and it will ask the large language model using the phrase here, it just started raining. This information is given to the large language model. Nothing more. And the large language model now will take a look at the actions and will decide if there is any action to be taken when it starts raining. Okay, we will see here nothing of this has something to do with raining. Maybe here report weather forecast, but it's more a forecast that the weather will change in so many minutes, so we will define our own action. Okay, we do this. And the action we want to define is start wiper. Call this function if it starts raining. And this description is very important because the LLM will get this information, and this is the way to describe the purpose of the action to the LLM, so it can decide if it can use it or not. Learning phase means that this action is available after the first few laps. No, it does not need a learning phase. Confirmation means the typical reaction of the assistant, okay, I understand you, give me a minute, and stuff like that. We don't need this either. So we have said it is a function in the controller. We have different choices here. And yeah, now what is a controller function? And okay, let's go back to the documentation and take a short look at the controller. And these have been there for several years now. These are built-in actions of the simulator controller you can use in your scripting. And one is, for example, trigger, which sends a keyboard command to the currently running simulator. And now, using this, no, that was this one. We say, call the function trigger in the controller with the argument control V. Control V means yeah, this axon graph, I think, stands for the control key, and V for the V key. This is also documented here as the special symbols for hotkeys. And yes, now we will call trigger with control V. This control V will be sent to the simulator, and this will start the windscreen wiper if you have set control V as the binding for the windscreen wiper. Okay, looks good. This will work. Let's clone this one. Say stop wiper. Call this function if it stopped raining. And let's assume that the command here is Alt V. Alt is represented by the exclamation mark. So, two very simple actions using built-in functionality of simulator controller, which already has been there, and the LLM decides to call these two actions depending on the event: rain started, rain stopped. Okay, let's get a little bit more complicated. We will define our own event now. For whatever reason, I want to trigger something whenever a new lap starts. for example, I have connected a sim hub and I want to display a checkered flag on my dashboard. Okay, it's a little bit unusual, but let's take it as an example. Okay, we will go to the events because yeah, now we don't have any event available that the new lab started. We will create a new event. We will create it as a rule because we now need some scripting. Name it new lab. Signals that the new lab just started. And I have prepared something for this. Okay, what is happening here? Whenever the built-in fact of the knowledge base, let's take a look here at the picture again, part of the rule engine are facts. And yes, in the documentation is a description, how they look like, what facts are available, and so on. And one very important fact is the lab fact, which is the number of the last finished lab. And this notation says whenever this change takes some action, and what we do now here is that we call this rule signal new lab. The last lab is given as an argument here. The new lab is the last lab plus 1. Okay, we finished lab number 3, now we are in lab number 4. And now we raise the event new lab with this new lab number as an argument. So the event signal is new lab. This signal has one parameter, which is the lab number. It's an integer and it is required. And now we have all this at hand to generate the phrase, and this is the important thing, which will be given to the LLM to describe what just happened. And the phrase will be, we just started a new lab with number, and now this as variable. So it is using this parameter here and inserts it in this place and send this to the LLM. Okay, so let's save that, and now we will have to define an action to use this. And for demonstration I have a very simple action. Started. Call this a new lab starts. Or better has been started. We will not use it's a rule, and it has one parameter because we want to take the information which has been available in the signal. Integer required, the number of the new lab. Okay. The most simple action here is whenever the lab number changes, call assistant speak. It's one of the built-in functions, and the assistant will tell you hello new lab. Okay, let's save that. Save this here. Save the complete configuration, and let's restart our race engineer simulation, and let's see what happens.
This is Tom. I will keep the car running today. You can call me anytime if you have questions. Good luck. Hello, new lab.
Okay, we have seen this is information window which has popped up. It's in debug mode. That the event new lab has been signaled, and the LLM decided to use the action we just defined, and yeah, told us hello new lab as expected. Okay, let's make it a little bit more complicated. We want the LLM to use the lab number in the phrase. And this code will look like this. It's a little bit more complicated because now, okay, we have to take an intermediate step. We will append hello new lab and the lab number into the message variable, and then this message variable will be given to assistant speak. Okay, save it, restart.
This is Tom. I will keep the car running today.
Oh, it's my
You can call
fault.
me anytime
I
if you
haven't
have
saved.
questions. Good luck.
It will do the same as before. So I have to stop it. And first apply the new configuration. Okay, next try.
This is Tom. Feel free to reach out to me at any time. Hello, new lab 3.
Okay. Quod erat demonstrandum, or something like that. Okay, before we go to the next level of the rabbit hole, any questions up to this point? No? Okay, then we will go to the strategist. The strategist has also some built-in events, and I have included 2 events which were not available before for demonstration purposes. These events are raised when a position has been gained or lost. So you have a position gained event or position lost event. The event is quite simple, just a few lines of code. To calculate the condition is we have to have a variable where the last position must be stored, and whenever the position fact in the rule engine, which is this one, changes, and if it's smaller than the last position, then we will have gained 1 or more positions, and the last position and the new position will be given as arguments here to the event, and the same is for lost. The only difference is this one here, and that we will have a position lost event. And yeah, what can we do with this? We can give the strategist a new voice information capability so that he will blame you when you have just lost a position, or he will give you kudos for being a great driver when you gain some positions. Okay, let's do that. As said, the events were built in, but no actions for this has been built in, so we have to create our own ones. Okay. It is once again a rule. Announce position change. Call this when error position change occurs. Two parameters, previous position. By the way, it is not a good idea to abbreviate that, because the LLM will look at the names of the parameters, it will take a look at the texts here, and this all helps for the LLM to understand what this action do and how it should be called. So be as descriptive as possible. It's integer, it's required, the position before the position change. New position. Okay, once again, it should be available all the time. We will do not want any special confirmation, like in the planned pit stop action where he says, okay, just give me a few minutes. And this is the code. It's a little bit longer now. Let's extend the window. It has two condition rules. The first one is the new position is larger than the previous position. We have a position lost, so call this one. If it was smaller than the previous position, we have gained a position, so then call this one. Both with the arguments we have described here. And yeah, it's easy. In the lost event, we will take the difference between the two positions and will be blamed. And if we gained a position, yeah, we will have some kudos here. Okay, let's do this, save this, apply. Stop the race engine here. And now we have to start the simulation of the strategist. Okay, let's go.
Hi Oliver, I am Andrew. I will watch the race and find the best strategy for you.
There are several position changes upcoming. I think they will start here. Yes, there.
Fuck, you lost 1 positions. Great, you gained 2 positions. Fuck, you lost 2 positions. Oliver, we have not developed a strategy for this race. You are free to choose your pit stops on your own, but you can use the full course yellow for a pit stop, if necessary. Fuck, you lost 13 positions.
and so on. Okay, any questions at this point? If not, then let's go to the ground level of the rabbit hole. As you've seen so far, let's take a look again at the picture. We had very precisely described events, and we also had some very narrowly focused actions. This is more or less the way the rule engine is working anyway, so it is not as free as the LLM might be able to handle. I have run several tests in the direction to only give the LLM the knowledge base and a very large set of actions, but no precise event. Just take a look at the data and decide what to do. And let's check out how to do this. We go again to the event editor, and the idea is that you can, I haven't introduced that before, that you can enable or disable each event individually. To be precise, you can set it as active or inactive. Inactive means it is not sent to the large language model, it is handled by the rule engine as it was before. For example, here, damage detected, the large language model will not get any information about damage, the rule engine will take responsibility, and all the events can be activated or deactivated according to your personal preferences. But there's a different one. When you say that the event is active but disabled, means that the rule engine will signal the event, but the large language model will never act upon this event. So in effect, the damage detection is disabled by doing this, but the event is still there. And let's use this to come to the situation where everything will be handled by the large language model. So, okay, this is our own, so I will deactivate it. So I deactivate every handling of any event by the rule engine, and we now have to define one new event which says inspect data. It will have no parameters. The event signal will be inspect data. The phrase will be, this is what is sent to the LLM. Take a look at the data and do whatever is necessary. And the rule for that is very, very simple. It's just one line. What is happening here? If all of the following conditions are met, the first one says if the lab number is greater or equal than the learning labs, You know, there is a phase where the knowledge base of the rule engine is being populated during the first 2 or 3 labs. And whenever we have an update of the knowledge base, whenever something changes in the knowledge base, raise this event, which will result in the LLM being activated with this command. All other events are suppressed, so this one is the only one.
Question?
Yeah.
How does the LLM know what's necessary? Does it know you want to win the race?
Yeah, interesting. That's the question, indeed. And as I said, I have run several tests using different large language models, and the result is that the very expensive flagship models which are now available, for example GPT-4o from OpenAI or Claude Sonnet from I don't know what company has just released that, they are quite smart. They don't know how to win the race, but they know, for example, that that fuel is running low, that a pit stop might be a good idea. They know how to calculate lap time differences after damage. Everything which has been done by the rule engine, more or less hard-coded in the past, can now be done in the LLM. And I'm very, very sure that the exponential intelligence increase we see in large language models today, in, let's say, 1 or 2 years, this one will be the only event you will need. At the moment, there are still some problems, some errors and stuff like that, but you can try it. I've tried it, and I decided to stay with the more traditional approach for the moment, but the results are really promising. And the current architecture I've built is built in a way so we are prepared for the future. Okay, that's it, folks. Any questions?
Yes, as always.
Yeah.
As I understand it now, you can define events and actions to be taken when certain events happen. Can you also ask the large? Is this always a one-time action, or can you ask the LLM to repeat actions based on the conditions?
Yes and no. The LLM, as we have them today, are not active, will not get active on their own. They always need to be asked something, need to be triggered. They have no sensory environment like eyes, ears, and stuff like they have. Because of that, we do not have the super intelligence already. But what you can do is you can, as I have done here, for example, you can define an event which runs whenever something changes, whenever anything changes. And this can be used to create a repetitive task, for example. I already posted in the discussion channel of our Discord that I made some very promising tests for using an LLM for strategy development. And the trigger will be, okay, each lab, take a look at the strategy. Can we improve something? Question answered?
Yes, I guess it's a combination of the last rule you showed and the ones you showed before.
Yeah, exactly that. Yeah. Okay, any more questions?
Yeah, one last question. Can we request you to program some actions?
Yes, of course. In the documentation, I already stated that I am very sure that this is not the average Joe stuff, and that should be no offense. It needs some development skills for sure. It's not as complicated as building a Windows application, but you have to have a good understanding of logical programming and stuff like that. And yes, because this is something not everybody has in his backpack. If you need an event or a special action, if you want to connect your assistant to your SIM hub dashboard and so on, let me know and we will see what to do. And if it takes a few minutes, you see, it's always, most of the time, a few lines of code. It's okay if it takes a few days. Let's talk about some donation, and we will do it. Yeah. Okay. Any more? Seems not. Then thank you for participation. I promised at the beginning that this is a rabbit hole. Yes, it's complicated, it's deep, it's dark, but it's very, very promising for the future. Thank you and bye-bye. See you next time.